Hello, class 10th. Today we are going to start with the first chapter of a science that is chemical reactions and equations. We are familiar with many chemical changes occurring around us in our daily life. So, in this chapter, we will be discussing about types of chemical reactions and how to balance these chemical equations. So, let's start with taking some examples like a freshly cut apple exposed to atmosphere becomes brown after some times. Iron articles such as a pan or a nail or tawa gets rusted when left exposed to humid atmosphere for a long period. Cooking of food is also a type of chemical change as the raw vegetables used for cooking food cannot be brought back again. Food gets digested in our body with the help of enzymes in stomach and intestine. We respire to get energy from food. So, students, we need to breathe in clean air and free of COVID 19. So, students, stay home and stay safe. All these chemical changes can be represented as chemical reactions. So, what is a chemical reaction? A chemical reaction is a process which transforms one or more substances into new substances. A chemical reaction is a process which transforms one or more substances into new substances. Let's take some examples. On mixing clear nitrate solution to clear potassium iodide solution, we get yellow precipitates of lead iodide. Second example, on burning magnesium ribbon in air, we get ashes of magnesium oxide which are gray in color. Magnesium oxide is represented as Mg and capital O. So this is a combustion reaction. Third example, when you add zinc granules to dilute sulfuric acid, we get hydrogen gas. Hydrogen gas is liberated in this reaction. The chemical reactions are often accompanied by some changes which can be easily observed. The easily observable changes which take place as a result of chemical reactions are known as characteristics of chemical reactions. Some characteristics are change in state when wax burns to form water vapors and carbon dioxide, change in color when iron rusts to form reddish brown color, formation of precipitate when lead iodide precipitates were formed on when lead nitrate and potassium iodide were mixed, evolution of a gas when hydrogen gas was evolved when zinc granules were added in dilute sulfuric acid, and change in temperature when slaked lime is formed with quicklime and water, there is increase in temperature. Now let us learn how can we represent a chemical reaction. So we can represent it with the help of a chemical equation. So what is a chemical equation? The chemical equation is a written representation of what happens during a chemical reaction. It includes chemical formulas and symbols. It is the shortest method to represent a chemical reaction. Example of how we can represent a chemical reaction with the help of chemical equations. So there are certain parts of the chemical equations. This equation shows the representation of formation of water vapors with the help of hydrogen gas and oxygen gas, which combine to form water vapors. So the left hand side of the arrow represents the reactants and the right hand side represents the products. Reactants react to form products and the arrow in the middle tells us about yield. So it means that hydrogen gas reacts with oxygen to yield water vapors. There are numbers written in front of the atoms of reactants and of products which is called as coefficient. For example, here 2 in front of hydrogen gas. Now this is done in accordance to balance the equation according to law of conservation of mass, which we'll be studying later. So now let's see, you can see that in front of hydrogen there is written small g in bracket and same as in front of oxygen. Now this small g is the state symbol which represent gas. So a chemical equation is also written in form of state symbols. L represents liquid, S represents the solid state, and AQ represents the aqueous state of, of that element. So now there is a difference between small l and AQ. AQ represents the solution of a solid in water and L represents the liquid state of that atom. A chemical equation tells about the recipe of a chemical reaction. Now, in this particular type of reaction, we can see that two molecules of hydrogen gas reacts with one molecule of oxygen gas to yield or to give two molecules of water vapors. This also gives the ratio of the atoms acting to form the product. You can also say that 2 moles of hydrogen reacts with 1 mole of oxygen to produce 2 moles of water. In other way, we can say that students, you should keep in mind that the coefficient 2 does not give the exact mass of hydrogen gas used, and 2 in front of water does not give the exact mass of water formed. This 2 tells you about, gives you the ratio of the reactants reacting and the product formed. So to know the exact masses of the reactants, you need to know the masses of these elements from the periodic table. So 2 moles of hydrogen will give you 4.04 grams of hydrogen. 1 mole of oxygen is 32 grams of oxygen, giving 2 moles of water. So 1 mole of water is 18 grams. So 2 moles will be 36 into 0.4 grams of water. Students see it carefully that the sum of the reactants given is equal to the sum of products formed. So this will be true for any of the chemical equation, and this is according to the law of conservation of mass, which states that in a chemical reaction the total mass of the reactant must equal the total mass of the products. In addition to the masses being equal, the number of times each atom appears in the reactant and product side must be equal. That is, the number of atoms in reactant side should be equal to the number of atoms in the product side. So this law is related to the balancing of unbalanced chemical equations. So according to law of conservation of matter, in a chemical equation, matter or atoms should be equal in both the sides. So in this particular reaction, you can see the number of hydrogen atom in reactant side is 2. Hydrogen gases are 2. There is 1 molecule of oxygen, and on the product side 2 molecules of water. If we write the reactants and the product separately, hydrogen here is 2 into 2, 4, and oxygen atoms are 2. And similarly on the product side, when you multiply 2 of hydrogen with 2, 2 into 2, 4, and oxygen is 2. So in the both sides, the number of hydrogen atom in reactants is equal to the number of hydrogen atoms in products. And similarly, in case of oxygen, number of atoms in oxygen is equal to the number of atoms of oxygen in the product side. So this thing is applicable in all the chemical equations. So this particular type of equation we call as the balanced chemical equation. So this was according to law of conservation of matter. Now before solving some other example, we need to know the symbols of certain elements which you may have forgotten. For example, if you look at aluminium, it is represented as capital A and L. Students, we need to know the symbols because we cannot write the complete spelling of each element and making the writing of a chemical reaction very tedious. So there are some other examples of writing the polyatomic ions and the monatomic ions. Here are the valencies given of certain elements and certain polyatomic ions. For example, if you look at the monoatomic ions like sulfide having -2, we can just write as capital S, oxide capital O and -2. And if you look at the polyatomic ions, you need to know the valencies of each, and we'll look further for some other example of positive ions. You need to know about their valencies, their oxidation states. Like hydrogen, it is +1, and similarly it could be hydrogen can also be written as negative ion, which we call as hydride. I hope you remember this in your ninth class. And look at the +2 valency charges like copper +2, barium +2, then calcium is +2, mercury we write as capital H and G, ferrous or iron we write as F and E, magnesium as M and G. Now let's continue by taking some more examples of zinc reacting with hydrochloric acid, giving zinc chloride and hydrogen. Now this reaction does not tell you about how many zinc metal will react with how much amount of hydrochloric acid. So we need to balance this equation. We'll write the number of elements in the reactant side and in the product side in the same way, because there are same number of atoms, same types of atoms present in both the sides. So if you write zinc, we look at zinc, there is just one atom, hydrogen 1 and chlorine 1, and similar in the product side we will write the number of atoms present. Zinc is 1, hydrogen 2 and chlorine 2. So this equation is not balanced. So to balance, we'll look at the hydrogen. We'll balance the hydrogen. We'll write 2 in front of HCl on the reactant side. And so we'll now again count the number of hydrogen atoms in reactant. Hydrogen will become 2 and chlorine also 2. Now we can say that this equation is balanced equation. Now I'll take another example, aluminium oxide reacting with lead to form lead oxide and aluminium. Students, look that there are same types of atom in both the side. No new atom is formed. So when we'll write the reactants and the products, aluminium is 2 here in the reactant, oxygen is 3 and lead is just 1. In the product side, number of aluminium atom is 1. Oxygen 1 and lead 1. Look at the reactant side. Aluminium is 2, but in the product side, aluminium is just 1. Oxygen is 3 and on the product side, oxygen is 1. So we need to balance this equation. We'll write 2 in front of aluminium in the product side. So in products, number of atoms of aluminium is 2. And now we need to balance the oxygen now. So we'll write 3 in front of lead oxide in the product side. So we'll count. Now number of oxygen is 3 and now lead is 3 now in the product side. Fine. Now in the reactant side, aluminium and oxygen are balanced. We need to balance the lead now. So we'll write 3 in front of lead, and here the equation is now balanced because in the reactant side also now lead has become 3. Now look at the equation carefully. Aluminium 2 on both the sides, oxygen 3 in both the sides and lead in both the sides. That means this is all according to conservation of mass. Now let's take some more examples of polyatomic ions. Now polyatomic ions can be balanced as a group only as long as the groups remain on the product side. Let's take example of this. Like silver nitrate, when react with barium chloride, it will give silver chloride and barium nitrate. Now look at the polyatomic ion nitrate here. Nitrate is as it is on the reactant side. So we'll take nitrate as single ion. So we'll write now the reactants and products on both the sides. So the reactants, the atoms in reactants are silver. Nitrate, will take it as 1 because it is as such given in the product side, barium and chloride, and similarly same on the product side. Silver here is 1, nitrate in the reactant side just 1, and barium 1 and chloride 2. On the product side, Silver is 1. Nitrate, there is 2. Look at the bracket outside. It is 2 written there. So nitrate ions are 2. Barium 1. Chloride 1. So this equation is somewhat unbalanced. We need to balance this equation. So for balancing this equation, we'll look at the reactant side. We'll add 2 in front of silver nitrate. So number of atoms now in reactant side of silver will be 2 and nitrate 2. And on the reactant side, we need to balance now silver. So we'll write 2 in front of silver chloride now. So when we'll write 2 in front of silver chloride, silver will have now 2 atoms and chloride 2. Now look at the equation. The equation is all balanced. Silver 2 in the reactant side and 2 on the product side. Nitrate 2 in the reactant and product 2. Barium 1, here barium 1 and chloride 2 and chloride 2. Now take a look at some more examples of salts. If you might have forgotten how to write these. So if you take a look at potassium chloride, potassium with valency 1 and chlorine minus 1, it will give you KCl. And for example, barium sulfate, barium plus 2 sulfate, which is SO4 minus 2, will give you barium sulfate salt. Now try to balance the following chemical reactions. The first one, hydrogen sulfide burns in air to give water and sulfur dioxide. Second, zinc metal reacts with aqueous hydrochloric acid to produce a solution of zinc chloride and hydrogen gas. And iron sulfate changes to iron oxide, sulfur dioxide and sulfur trioxide gas on heating. Try to write these chemical reactions in the form of chemical equation with the state symbols and balance them. Thank you so much.